we're going to build a model that calculates the expected value of perfect information. The first thing you want to do is you want to replicate this screenshot down here in Excel. Now, I've already done that. As I read the problem, I'm going to fill in the information. A CEO needs to decide whether to invest $5.2 million to improve an existing product or $8.2 million to develop a new product. And there are two states of the economy, recession or expansion. Whether we go into recession or continue in an expansion is not going to change the cost of improving or the cost of developing this product, because we're going to spend the money now and then later we observe either continued expansion or sinking into recession. So this is 5.2 million for improving an existing product, and this is 8.2 for developing a new product. And they are the same whether we're in a recession or expansion. Now, if a CEO improves the existing product, so we're right here, the company's revenue will increase by 9.3 million if the economy continues to grow. $9.3 million increased sales from improving during an expansion. Company revenue will increase by only $6.3 million if the economy goes into recession. So this is only 6.3 million here. If the CEO decides to develop a new product, we're in this row, the company's revenue will increase $13.8 million if the economy continues to grow, but will decrease by 4.3 million if the economy goes into recession. Now, according to the company's CFO, she believes the probability of recession is 0.27. If that's true, then continued expansion must be 1 minus that probability. So the CFO projects what? The probability of the economy continuing to grow is 0.73. To find the answers to the remaining questions, we need to calculate first the payoff matrix. Improving a product increases sales by 6.3 million. To get that increase in sales, we have to net out the cost of improving. And then we do that for all the other cells in this payoff matrix. If there's an expansion, sales will increase by $9.3 million. But to get that increase in sales, we have to improve the product, which will cost 5.2 million. If we go into recession and we develop the new product, our sales will drop $4.3 million. So the payoff matrix for that outcome is this negative 4.3 minus the cost of developing a new product. If the economy continues to expand, our increased sales from developing the new product is 13.8. But we have to net out the cost of developing that new product. If we calculated a standard deviation on this row with just two numbers, it's pretty obvious that the standard deviation here for improving the existing product is going to be a lot smaller than the standard deviation of developing a new product. With a minimum of negative 12.5 and a maximum of 5.6, that variation is large. Improving the current product, that variation is much smaller because these two numbers, the smallest and largest, are much closer together. So improving is less risky. Developing the new product is much riskier. I'm going to put in parentheses low risk. And then down here, I'm going to put in parentheses high risk. So if we were risk averse, we want to avoid developing the new product. Now we want to calculate the expected increase in profit. To calculate the expected increase in profit, we have to multiply this increase in profit with its probability and this increase in profit with that probability. In order to do that, we use the sum product, the payoff matrix row that corresponds to improving the existing product, and the corresponding probabilities. So what this does is it takes B11 and multiplies it by B8, then adds that to C11 times C8. And that gets our expected increase in profit. Now, because I'm going to drag this down, I want to freeze this red row in row 8. Then I can drag this down. From lesson 8, the expected monetary value is the maximum of these two values. So all we're going to do here is type equal max. And then it's going to say the expected increase in profit is higher for improving the existing product than it is for developing the new product. Also, the risk, the variation in these two is much smaller than the variation in these two. So not only is it got a higher expected increase in profit, it's also low risk. So we're 2 for 2 here, right? So we're considering just improving the existing product. During a recession of these two, the maximum is 1.1. Of these two, the maximum is 5.6. If we know a recession is going to happen, we're going to pick improve existing product because it has a higher payoff. If we know an expansion is going to happen, we're obviously going to pick develop the new product because it's got a higher payoff. The expected value given perfect information is the sum product of this row and the associated probabilities. And it equals 4.385. The expected value of perfect information is going to be the difference of these two. You can think of it as how much we'd be willing to pay somebody who had this perfect information. We'd be willing to pay that person up to this value. There's a movie called Trading Places. And these two old white guys, they run this company named Duke and Duke. And Dan Aykroyd is the guy that runs the company. He's the one that makes the investment choices. He's the guy, he's the oracle, right? He's deciding go long, go short on various different commodities. He graduated from Harvard. He had all the advantages. Eddie Murphy is introduced to them in the movie. You have to watch it to find out how he was introduced to the Duke and Duke. He's very street smart. And the Duke and Duke decide to do a social experiment. They make Dan Aykroyd homeless and they lift Eddie Murphy from the streets into Dan Aykroyd's character's position. And he does very well. When Dan Aykroyd's character and Eddie Murphy's character find out about this, they decide to flip it on the Duke and Duke. And the way they do that is the Duke and Duke are paying a government insider to leak the crop report. The results of these crop reports the government issues will cause commodity prices to go higher if the commodity harvest is low. Because if there's a low supply, the price goes up. If it was a great year for this commodity and there was a massive harvest, that means a lower price. So there's a scene in which the Duke and Duke toss an envelope filled with cash to this government employee who has the crop report. And they're willing to pay for that information. This number here that we calculated, the expected value of perfect information, is how much somebody like the Duke and Duke is willing to pay a government insider for the report that the government's going to release to the public the very next morning. And that's how you can think of the expected value of perfect information. The expected additional profit of the improved product equals what? That's the 3.29 million. The expected additional profit of the new product equals only $0.713 million. Since the CO doesn't have perfect information, the CEO is going to go with the maximum, right? The expected monetary value is 3.29. That says the CEO should improve the existing product. If the CEO does this, the CEO can expect to raise firm profit by $3.29 million. Now, this is a good decision, right? Not only is the expected increase in profit higher for improving the existing profit, it's also much less risky. Now, if the CEO could hire Doc Brown to use his DeLorean time machine to go into the future to find out for certain if a recession will occur or not, the most the CEO would be willing to pay Doc Brown is this value here. He'd be willing to pay Doc Brown up to and including $1.095 million for that information. Duke and Duke were willing to pay that government employee with that secret crop report whatever money that was in the briefcase or the envelope, right? Now, the funny thing about the Duke and Duke is Eddie Murphy and Dan Aykroyd kidnapped the government employee, changed the crop report. So Duke and Duke got the wrong report. And when they went to make their bets the next day in the commodity market, they lost out. And Dan Aykroyd's character and Eddie Murphy's character made the opposite bet and made millions.